Okay, we covered last time that we have three possibilities, right? Upper tail test, lower tail test, or two tail test, right? We have the upper tail test when in my null hypothesis says less or equal, and in my alternative greater. We have the lower tail test when in my null hypothesis we have greater or equal, and in my null, and in my alternative we have less. And we have two tail test when in my null hypothesis says equal and the alternative says not equal. Okay? So far so good. Okay, so in any of these, it really doesn't matter what it is. Of course, this is alpha, this is alpha, this is alpha divided by 2, and this is alpha divided by 2, and again, alpha is the significant level. So let's draw, for example, an upper tail test. Okay? This is alpha, right? This value over here is the critical value. The critical value is the value that divides the rejection zone. This is the rejection zone. And this is the do not reject zone. So the critical value is the limit between the reject and do not reject zones. Okay? That is the critical value. How do you know what is the critical value? Well, it really depends on alpha. So we have the rejection zone, that is the shaded area. In the two-tail, we have two rejection zones. This one and this one. And of course we have two critical values because we have two rejection zones. In the two-tail test, we have two critical values, and it is the positive and the negative part. Once you understand these concepts, I mean, this is pretty easy. We have two zones, the rejection zone and the do not reject zone, and the boundary between the two zones is called the critical value. Then we have to compute a test value based on whatever problem it is, and the test value, if the test value is in any place in the rejection zone, what we do? We reject. What we reject? The null hypothesis. Remember, we test the null hypothesis, but what we really want to prove is the alternative hypothesis. That's how do you know how to formulate the hypothesis. Okay? So if my test value is over here in the rejection zone, I reject. What? The null hypothesis. If my test value is in any place in the do not reject zone, the conclusion would be do not reject. What? The null hypothesis. Okay? Easy. Simple. If you understand these concepts, guys, the rest of the chapter is, easy. Easy. So we test the null hypothesis, but what we really need to prove is the alternative hypothesis. So in the formulation of the hypothesis, you need to know what you want to prove. If the problem tells you, I want to prove if the mean is greater than 30. Well, what I want to prove, I put it in the alternative hypothesis. And the opposite to the alternative hypothesis is the null hypothesis, right? And always in the null hypothesis, we have the equal sign. Equal, greater or equal, or less than equal. Less or equal. Okay? That's basic. So, today we're going to cover hypothesis testing about the population mean when sigma is known. Hypothesis testing of the population mean. Remember, hypotheses are assumptions about the value of the population parameter. Okay? And the mean, the population mean is a population parameter. And the only thing that you need to know is how to calculate the test value. The test value, your book calls it Z of X bar, and that is equal to X bar. What is X bar? The mean of the sample. Minus mu of the null hypothesis. What is hypothesized? The mean is the mean of the null hypothesis divided by sigma over square root of n. Okay, and that is the value that you are going to compare with the rejection or not rejection or the not reject zone. That's it. As easy as that. And for this one, we use the standard normal distribution, standard normal distribution tables. Okay. That's it. Let's do a problem. That's it. I mean, that's the whole class. Right? Really? I mean, really. Let's do a problem. Problem for this. Let's do 9.3. That is part of the homework, but that's okay. Okay? I'm going to do two problems of this section, and a one-tail and a two-tail test. Okay, 9.3. It says, let me erase this. It says 9.3. It says, consider the following hypothesis. The null hypothesis, the mu is less or equal than 50, and the alternative that mu is greater than 50. And we have X bar is equal to 52. Sigma, or the standard deviation of the population, is 12. The sample size is equal to 36. And of course, my alpha is 0.5. Okay? That's it. Now, the first thing that we need to check is if it's an upper tail test, a lower tail test, or a two-tail test. What is this? It's an upper tail test, right? So we have an upper tail test. What is alpha? 0.05, right? This is 0.05. So what is this value over here? If we are dealing with the Z, and I gave you yesterday with the cheat sheet. If the area is 0.05, the value is 1.645. So So my Z value is 1.645 because my alpha is 0.05. Okay? Does anybody agree on the 1.645?
How do you figure that?
What?
How do you figure that?
How do I get that? It's from the cheat sheet that I sent you. But you should know from the previous.
Is it the same as what we did?
Yeah, but the same that we did in chapter 8, remember that we
okay,
have to
sure.
divide,
Yeah.
or it's in the book also. Yeah. Okay, so it's 1.645. So the next thing that I need to do is to calculate the test value and check if it's in the rejection zone. This is my rejection zone, and this is the do not reject zone. Right? The shaded is the rejection zone. The non-shaded is the do not reject zone. And of course, the critical value is that divides it. The critical value in this case is 1.625. Okay, because we're dealing with the normal distribution, standard normal distribution. Okay, what is the test value? So when you identify these, probably 80% of the problem is done. So the hardest part is to get into this part. What is the what type of test is that? Upper, lower, or two-tailed? And what is or are the critical values? Depending on if it's one tail, it's one critical value. If it's two tails, it's two critical values. And then calculate the test. With that, your book calls it Z of X bar. What is it equal to what? Equal to X bar minus mu from the null hypothesis divided by the sigma over square root of n, and that is equal, X bar is 52 minus 50 divided by 12 over the square root of 36, and this is equal to 1. Okay? So my test value is equal to 1. What is my 1 over here? This is 1.645. Okay, my 1 is here. What is the conclusion? What do I conclude from this test? Reject or do not reject? Do not reject. So the conclusion is do not reject what? The null or the alternative? No. Do not reject the null. So the real conclusion, or in talking to statistically, we have to say that we do not have evidence. That's what I want to see in the test. We do not have evidence that supports that the population mean is greater than 50. That is the statistical conclusion. We do not have evidence that supports that the population mean is greater than 50. So we don't have evidence that supports the alternative. Right? That's what I want to see in the test. I don't want to see, do not reject the null hypothesis. That's wrong. The real conclusion is that we do not have evidence that supports that the mean is greater than 50. Okay? When your boss asks you something to test a hypothesis, you're not going to say, well, I reject it. Then no. He wants to know what is your conclusion. Either you have evidence or you don't have evidence. Okay? And again, what you want to prove is the alternative hypothesis. But you are testing the null. So the null is the one that you reject or do not reject. That's it. Let's do problem number 4, which is the two-tailed test. Okay, let's do number 4 because I want to do the two-tailed test. Okay, guys, the book asks you to calculate the p-value. Okay, what is the p-value? The p-value is nothing but the probability that the z is, in this case, greater than my test value. This is my p-value. Okay? That is the p-value. When I have the test and I put it in my graph, the p-value would be this one over here. Why? Because it's an upper tail test. If it would be a lower tail test, it would be the left side. And if it would be the two-tail test, you have to multiply that p-value times 2 because we have 2 tails. That's it. Okay? That is the p-value. Now, when do you conclude to reject or do not reject using the p-value approach? If the p-value is greater than your alpha, what? You do not reject. Why not? Because it's not in the rejection zone. It's logical. It really doesn't matter what approach you use. And your book used the other approach that is called the critical mean or something like that. I mean, any approach that you use, it's okay. And any approach that you use has to give you exactly the same result. If you use 2 different approaches and from those approaches you have a different conclusion, then some of those approaches is wrong. Okay? So in this case, this p-value, of course, is greater than this one, that is my alpha. So I what? Fail to reject. I do not reject. Yes?
Okay. Is the p-value like the total area? Is that what you're trying to
Yeah, absolutely. The p-value is the probability that my z is greater or equal than my test, or my, what is called the z of x bar. Okay, so that is the p-value. And the book also explains more or less the p-value, but again, it really doesn't matter. So some of the problems ask you the p-value. What is the p-value in here? Okay, what is the probability? The p-value in this one is the probability that z is greater than 1, and that is equal to 0.1587. This is my p-value for this particular problem. So, is the p-value greater than alpha? Of course, alpha is 0.05. So I do not reject. Yes.
Did you go? Is it in the chart?
It's in the z table. Yes.
What's the sign of p-value? Is greater than or equal to what?
Over here,
No, up top.
p-value is the probability that z is greater or equal than that z of x bar. That's my test value. Okay. Okay. Let's do problem number 4. That again is part of the homework, but you know, I want to do a two-tail test. Problem number 4 says that the null hypothesis is that the mu is equal to 120, and the alternative is that the mu not equal to 120. We have, of course, x bar is equal to 111, sigma 26, n is equal to 40, and of course alpha is 0.5. Okay? Test that. Again, what type of test is this? One tail or two tails? Two tails, right? Two-tail test. And of course, my alpha is going to be divided in two zones, right? This is alpha divided by 2, and this is alpha divided by 2. So this is 0.025, and this is 0.025. And so I have 1.96 positive and negative 1.96, and these are my critical values. Okay? You're going to say, well, the alpha is exactly the same. How come you ended up with different critical values? Because in the two-tailed test, I have to divide my alpha in 2. So instead of having this equal to 0.05, this has to be equal to 0.025. Right? So that is why using the same alpha, we have different critical values. You need to understand this concept. In a two-tailed test, you divide your alpha in 2. So this area is not 0.05 like this one. This area is 0.025, such that my critical values are negative 1.96 and positive 1.96. That's it. So I have this rejection zone, and I have this rejection zone, and over here we have the do not reject zone. Okay? So if my test value is over here, or over here, or over here, or over here, or whatever it is, in the shaded area, we what? We reject. That's a rejection zone. But if my test value is any place over here, we do not reject. What? Then no. Easy. Guys, this is pretty easy. This is like preparing a cake with a recipe. You know, put the eggs and then put the milk and everything. Right? So it's easy. That's the steps that you need to follow. Okay, what is the test value? That's C of x bar is x bar minus mu from the null hypothesis divided by sigma over square root of n, and that is equal to 111 minus the mean of the hypothesis, 1 minus 120 divided by sigma 26 over square root of 40. Okay? And that is equal to negative 2.19. Okay? That is the value of my test. Where is that? In the rejection or in the non-rejection zone? In the what?
Non-rejection.
Who said so? Who agrees? Isn't the reject? I mean, we have a negative 2.19. You see? So there is more negative than the negative 1.96. You see? So it is in here. This is the negative 2.19. I'm going to erase this so I can draw my conclusion and everything, so you know exactly what the conclusion should be and why and so on. So, what is the conclusion? Reject or don't reject? Reject. Reject what? The null hypothesis. But the real conclusion is that we have statistical evidence that supports that the population mean is not equal to 120. So we have evidence that supports the alternative. You see? We have evidence that supports that the mean, that the population mean is not equal to 120. That's it. What is the p-value? Okay, so this number over here is negative 2.19. So my p-value is this one, is the pink one, times 2. Why times 2? Because remember that when we are dealing with the p-value, we have to multiply times 2 because we are dealing with a two-tail test. So my p-value is equal to 2 times the probability that z is less or equal than negative 2.19. So, and that is equal to 2 times negative 219 is 0.0143. So my p-value is 0.0286. Okay? So, is the p-value less than alpha? My 0.02 is less than 0.05. It is. So we reject. So really, guys, it really doesn't matter the approach that you use, either the test value with the critical values or the p-value approach, the conclusion has to be the same. So for this one, I conclude to reject the null hypothesis, and for this one, since my p-value is less than alpha, I conclude that I have to reject